Hello students, this is Sir Murtaza from Al Murtaza School and welcome you to another lecture of physics. So let's start. So first of all, we are going to talk about our agenda for this lecture, that what topics or what SLOs we are going to cover in this video. So first of all, we are going to look at the SLOs. So we are going to cover the following SLOs. What SLOs? In SLOs 1.4.1, which is convert the prefixes and the symbols to indicate multiple and submultiple for both base and drive units. We will cover this SLO and calculate the answer in scientific notation in measurements. So it means that in this lecture video we are going to cover two SLOs. Okay, and in these SLOs we are going to talk about first the prefixes and then we will talk about the scientific notation. Okay, so firstly we will be talking about prefixes. Okay, so this is SLO 1.4.1. So first of all, look at the definition of prefixes, that what is prefixes. So prefixes are the words or letters added before SI units such as kilo, mega, giga and milli. Okay, so what are prefixes? As the name indicates, pre means before. So what does before means? You have seen that whenever we are using SI units, we use some words. These words are called as prefixes. And what are these words? These words could be kilo, mega, giga, and milli. Okay, so these are actually prefixes. Kilo, mega, giga, and milli. These are the examples of prefixes which we use in our SI units. Okay, and the prefixes are useful to express very large or small quantities. So why do we use prefixes? We use prefixes to express very large or small quantities. How? We will look in our further elaboration. Okay, so let's move on. Now here I'm going to show you some of the prefixes. Okay, here I'm going to show you a table where you could see the prefixes, their symbols and their multipliers. How? Let's look on to this. So here you have a table. In this table you have seen that there is a list of prefixes. Okay, here is its symbol and here is its multiplier. So what students you have to do, you have to remember all these prefixes because this could be asked in your exams or in MCQ. This could be asked from you. So you have to remember all of these. But let me talk about some of the prefixes which we commonly use in our studies. Commonly we use tera, we use giga, we use mega, we use kilo. Okay, these are some of the prefixes. And what does giga represents? Giga represents exponent 9, mega represents exponent 6, kilo represents exponent 3. Okay, similarly you have been look onto these prefixes too, which are deci, centi, milli, micro, nano, pico. Okay, what does this represent? Deci is exponent -1, centi is exponent -2, milli is exponent -3, micro is -6, nano is -9, and pico is -12, and so on. But you just don't have to remember or memorize those prefixes which I have indicated. You have to remember all of these prefixes. Okay, so this is the list of prefixes which you student have to remember, and it can be asked in your questions. Okay, so let's talk more about prefixes. So before going to some practical question, there is some more thing, which is multiples and submultiples of length. Here we will just specifically talk about length. You should remember that the SI unit of length is meter. I'm showing you a table. Okay, in this table what I have shown is 1 kilometer is equal to what 1 kilometer represents. It represents exponent 3 meter. 1 centimeter represents exponent -2, 1 millimeter represents exponent -3 meter, 1 micrometer is exponent -6, and 1 nanometer is exponent -9 meter. So these are some of the multiples and submultiples of length which we commonly used in our studies or in our investigation about length. Okay, so now what I'm going to do, I'm going to show you some example questions. In those questions, we will be having a big number, a number which have a lot of digits, and we will use prefixes in order to write those big digits into smaller number of digits. Okay, so let us consider some examples using prefixes. Here, I have example number 1, which is around 48 lakh, and this is what? Okay, this is a very big number. What I'm going to do, I'm going to use prefixes. How? Firstly, I have to write this big number as 4800 into 10 raised to the power 3 watt. Okay, now what I have done is I have shifted my decimals. Okay, so what I have done, I have shifted 3 decimal towards left, and I have added 10, multiplied 10 raised to the power 3. So you have to remember, whenever I shift decimal towards left, so the power will be positive. Okay, here the decimal is here. I have shifted it 1, 2, 3. So it becomes 4800. I have written 4800. Okay, so as I have shifted decimals 3 times towards left, so it becomes exponent 3 watt. Okay, then what I have done, I have replaced exponent 3 by kilo. Okay, so it becomes 4800 kilowatt. Okay, so in this way we have written this this number, which has 1 2 3 4 5 6 7 8 digits into 4 digits. Okay, sorry, 7 digits. 1 2 3 4 5 6 7. It has 7 digits. Sorry, 7 digits it has. I have written it in 4 digits, and written it as kilowatt. So I have used my prefix, which is kilo. Okay, let's look at another example. So in this example, don't bother about what this number actually represents. It is in crores. So this is, a big number which has a lot of digits. It has 1 2 3 4 5 6 7 8 9 10 digits. Okay, so it is being written in hertz. So what I have done is I have reduced it into 4 digits. Okay, so here I have shifted the decimal 6 times towards left. That is why I have written 10 raised to the power 6, or you could say it as exponent 6 hertz. Then I have replaced exponent 6 by mega. Okay, so in this way, this big number with 10 digits, I have written it with 4 digits by using prefixes mega. And in the first example, which is a number of 7 digits, I have written it in 4 digits, and I've used a prefixes kilo. Okay, it is not always important that you always use kilos or megas. It depends upon you. Just you have to use prefixes in order to write a number which has a lot of digits into smaller number of digits. Okay, so this is all about prefixes. Prefixes are those words which are used before an SI unit. And why is it used? It is used to express very big quantity or even very small quantities, okay, into smaller number of digits. Okay, so now we are going to talk about scientific notation. Now, scientific notation and prefixes are interrelated terms. How? First, look at the definition. So the definition is, in scientific notation, a number is expressed as some power of 10 multiplied by a number between 1 and 10. Okay, let's read some more. For example, a number which is 62750 can be expressed as 62.75 into 10 raised to the power 3, or 6.275 into 10 raised to the power 4, or 0.6275 into 10 raised to the power 5. So what I have done is I have expressed these numbers into by showing 10 raised to the power a number. So what I have done is I have shifted the decimals. Okay, so here I have written 62.75. So I have shifted the decimal 3 times, 1 2 3, so it becomes 62.75. As I have shifted towards left, so the power is positive. Okay, or I could also write it as 6.275. Here I have shifted the decimal 4 times toward left, so that is why the power is 10 raised to the power 4. Or I could write it as by shifting my decimal 5 times toward left, and the power will become 10 raised to the power 5. Okay, now all these are correct. This form, this form, this form, all these are correct, but there should be a standard form. But the number that has one non-zero digit before the decimal, that is 6.275, preferably be taken as the standard form. Okay, so the standard form is you have to write one non-zero digit before the decimal. Okay, so before the decimal there should be only one non-zero digit. Non-zero digit means the number which is not zero, other than zeros. So here you could see that there are two non-zero digit, so it is not a standard form. Here you can see that there is only one non-zero digit before the decimal, so this is the standard form. And here you could see that in the third example that there is no non-zero digit, so this is not a standard form. So the standard form for a scientific notation is there should be only one non-zero digit before the decimal. Okay, so this is the correct or the standard form. Now, similarly, there is another example. Similarly, the standard form of triple zero 45 second is 4.5 exponent minus 4 seconds. Okay. Now this is a very small number. What I have done is I need one non-zero digit before the decimal. Okay. So for this, I have to shift my decimal towards right. And one thing you have to also remember that whenever I shift the decimal towards right, so the power would be in negative. Okay. So here you can see that the number is 0.00045. So I have shifted 1, 2, 3, 4. So the number becomes 4.5 and the power will be exponent minus 4. Why minus 4? Because I have shifted 4 times the decimal and I have shifted the decimal towards right. So it is in negative. Okay. So this is about scientific notation. Simply in scientific notation, we use 10 raised to the power 4 a number in order to express very large or very small number. Okay. Now what we are going to do, we will be having a quick quiz. Okay. In this quiz, there will be a number and we have to use scientific notation in order to express it. Okay. So the question is, write the numbers below in scientific notation. So the number is, firstly, I have this huge number. Okay, again, don't bother about what this number represents. Again, this is in crores. So I have to express this huge number in scientific notation. Okay, and remember, the standard form of scientific notation is that we just need one non-zero digit before the decimal. Okay, so the standard form will be 3 exponent 9. Okay, how 3 exponent 9? So here you can easily see that the decimal is here. I have shifted it 9 times toward left till here. Okay, so it becomes 3, and as I have shifted 9 decimals towards left, so the power will become 10 raised to the power 9. Okay. Similarly, I have another example. In this example, I have a number 0.1234567 zeros and 16 grams. This is a very small number. Now what I have to do, I have to write it in scientific notation and in standard notation. So in standard notation, where do I need my decimal? I need my decimal here so that it becomes 1.6 because I just need one non-zero digit before the decimal. So the answer is 1.6 exponent minus 7 grams. Okay, so how we have find this? As I have shifted the decimal 7 times towards right, or you could say 7 digits towards right, so the power will become 7. So as I have shifted it towards right, so the power is negative. So its standard notation is 1.6 exponent minus 7 grams. Okay, so this is it for this lecture video. In this lecture, we have covered two SLOs. One is prefixes and other is scientific notation. Okay, so hopefully you have understood all the topics very well. And soon, inshallah, we will be going to meet for another lecture. So till then, goodbye.